Hello, in this video, I will walk you through a Jupyter Notebook example that demonstrates how to compile a custom deep learning model and perform inference using that model on a TI-AGI processor. So when selecting an example for this purpose, you can go with one of three notebooks, one for each runtime engine. For this tutorial video, I will choose the TVM Neo AI DLR example. Once you make that selection, this Jupyter Notebook will appear. In this notebook and in all the others, we first describe the particulars of the example, such as task type, runtime engine, dataset on which models were trained, and the dataset on which the inference will be performed. In this particular example, the task type is classification. The compiler is TVM. The model is deployed on the device using the Neo AI DLR interface. The dataset used for training was ImageNet, and the inference will be performed on some sample images saved in the workspace. Below that, we have some additional info, but let's now directly go to the script, since all this information will be covered in the example. The first bit of code loads some needed libraries. The next segment loads the deep learning model in its native framework. Here we choose ResNet 18, trained using ONNX. Notice the location where the model is stored. Then we convert the model to the RelayIR format before creating deployable artifacts. This is a necessary intermediate step when you're working with Neo AI DLR. Now let me explain what we're doing here next. As you may be aware, for different deep learning models, you need to pre-process images differently based on the training framework or the dataset. So we need to define a function that takes care of that step. The function we show here pre-processes images to run on models trained using ONNX and the ImageNet dataset. Since the steps are self-explanatory, I'll leave it up to you to go over them. Next, we convert the RelayIR model that we created above into deployable artifacts with layers offloaded to TIDL. The deployable artifacts and all the intermediate files are stored in the output directory defined below. So if you look at the code below, you will notice that we are using some images for the compilation process. The reason we need images here is because TIDL uses quantized models for inference, and most models are natively in floating point. Therefore, these images are being used to calibrate the quantized network to perform approximately as well as the floating point network. Finally, we deploy the model using the Neo AI DLR interface and collect some benchmarks using the predefined getTI_benchmark_data function. We also encourage you to take a look at the other notebooks under the custom tab to understand how to compile and deploy models using other runtime engines. If you have any questions, please visit the FAQ section. If you can't find your answers there, please use the E2E service. Thank you for your attention.